welcome back once again. So just imagine if you come across this kind of a question in your exam. So let's say you came out, you are writing your exam, maybe post-training jam or what exam, maybe even nursing exam, and they tested you with this kind of a simple question. This question, let's say number 5 physics question. What will you do? Will you skip, or will you just ignore it, or will you just guess the answer? Now, okay, so let's get to it. Let's look at the question and see if the question is actually difficult, because it's actually a question under energy, actually particularly energy conservation, energy conversion. Yeah. So it said a 5 kilogram mass is dropped from a height of 30 meters above the ground. Determine the velocity of the mass when it is 18 meters above the ground. And many students have, I don't know, there are many approaches to this question. Some person will decide to say, okay, let me go and look for my velocity using v squared, that's equation of motion, and so on and so forth. But the easiest and the most simplest way you can actually use or to solve this question is actually the energy conversion. But before I talk about that, since they asked us to find velocity and we have height there, so let's quickly dive into energy bits. Firstly, what is energy? We already understood that energy is the capability or the ability to do work. Your ability to do work is what is known as energy. And energy have various forms. There are different forms of energy. You have chemical energy, we have light energy, solar energy, and so on and so forth. Nuclear energy. There's also an energy known as mechanical energy, but that's our key focus anyways. What is mechanical energy? Mechanical energy is actually the energy that is used to do work. So anytime you hear mechanical energy, what should be coming to your mind is that it is the energy that is used to do work, mechanical. So the energy that is used to do work is called the mechanical energy. So don't forget this. This is why we say energy is the ability to do work. There are two kinds of mechanical energy. Okay? We have the kinetic and we have the potential. So now I'm going somewhere, just follow me, okay? Because I'll be using this one question to explain some things that students find confusing most time regarding this aspect of mechanical energy. So mechanical energy is the energy that is used to do work. Is that not it? We also say mechanical energy is two types. We have kinetic and we have potential. Now this is it here. Kinetic energy is the energy that is due to motion. Is a type of mechanical energy. So a type of mechanical energy that is actually used to carry out motion. So when you hear a vehicle moving, a boy running, any energy that is required to carry out that motion or to carry out that work that deals with movement, it is called kinetic energy. And this is why what aspect or what terms in physics that actually describe motion is velocity. Is that not it? This is why kinetic energy is related to velocity. So we say kinetic energy, the formula is what? Half mv squared. Remember, I'm not teaching energy. I just want to quickly brush it so that we can understand this. It's called half mv squared. Then when we talk about potential energy is actually the energy that is due to the virtue of position of the object from the ground. There are two things about potential energy. One, by virtue of the position of the object. Two, when the object is at rest. And this is why, have you ever heard somebody say, oh, this guy has a potential of becoming something? That is, there is something in him that can help him become something. So anytime you hear potential energy, it is the stored energy. Take note. So when you hear stored energy, the energy that is stored, it is called potential energy. This boy, I see a potential in you. The potential is, you are seeing the potential, it's not there. You know that there is something inside of him that can help him become something. That's why I say, I see a potential in you. Is that not it? So when you hear potential energy, it is the energy that is stored within a body. So this potential energy is capable of making that thing produce a result. So potential energy can be converted into kinetic energy, and that's where energy conversion came from. That's first. Potential energy is also an energy that is due to the virtue of the position of the object from the ground. So as an object is from the ground, the height of an object from the ground gives you the potential energy. So the energy that helps an object stays at a particular height from the ground is called the potential energy. And this is why potential energy is related to height. So if you want to find the formula for potential energy, you say it's what? mgh, mass times gravity times the height. So let's take for example a mango fruit that is on a tree. What energy is associated with it? It has potential energy. So if I pick up a stone and throw it at the mango fruit and the stone hits the mango and it begins to fall, the potential energy will begin to drop to change to kinetic energy. Now this is one beautiful key point I want you to take note of, because it comes out in past question. When you study energy and work energy and power, when an examiner want to spoil your head, I've seen so many people make mistake with this thing. So when they say the energy conversion in a closed state, energy can never be created nor destroyed, but can be converted from one form to another. Is that not the law of energy conversion? So they said in a closed state. Why do we call it a closed state? So many of you will see in your text will say, if they say state the law of energy conversion or energy conservation, rather, if they ask you to state it, you just define it that in a closed state, energy is neither created nor converted, neither destroyed, but can be converted from one form to another. What does that mean? That means that you cannot create energy and you cannot destroy energy. Energy is always coming from one point and it keeps changing, I don't know go that deep into that. When I make a note on that or a video on that, so I'm going to look at that. But this is what I'm trying to say. You see this mechanical energy. This mechanical energy is constant. It does not change. Mistaken. Mechanical energy is constant. It does not change. Kinetic energy is not constant. Potential energy is not constant. So because kinetic energy and potential energy is not constant, this is why we have initial kinetic energy, final kinetic energy. This is why we have initial potential energy, final potential energy. And the beautiful thing about this whole thing is that mechanical energy is equal to kinetic energy plus potential at every given point. And let me give you an illustration of what I'm saying. Now see this. I have a body at this point. This is the ground. This is the ground, okay? So I have an object at this point here. This object began to fall downward. But before the object started falling down, the energy it has at this point is what is called potential energy, because energy due to height is potential energy. Energy due to motion is kinetic energy. So at this point here, because the object, let's say the height of the object above the ground, let's call it h, okay, above the ground. So at this point here, because the object has not started falling, its initial velocity is 0, is that not it? So kinetic energy at that point is what is 0. So kinetic energy is 0. Now, does this object has a height? Yes. The height of this object from the ground is h. So the potential energy at this point is maximum. So it has a maximum potential energy, but 0 or minimum kinetic energy. Now, the beautiful thing about this is that, okay, I want to ascribe value. Let me just ascribe value so that you know what you understand what I'm trying to say here. I want to explain to you why mechanical energy is constant, but kinetic energy and potential energy is not constant. Let me ascribe value. Let's say h is equal to 5 here, and the object has a mass of 2 kilograms. So we say the potential energy will be 2 times 5 times 10, because 2 times 10 times 5. So the height is 5, right? mgh, mass times gravity times height. You see it? Mass is 2, gravity is 10, h is 5. 2 times 10, 20. 20 times 5. 5 times 2, that's 100 joule. So at this height here, the potential energy is 100 joule, but the kinetic energy is 0. Why is the kinetic energy 0? The kinetic energy is 0 because at this moment, it has not started falling. It has not started falling, so kinetic energy is 0. It has no velocity. The moment there is no velocity, there is no kinetic energy. The moment there is no height, there is no potential energy. So because it has a height of 5 meters here, it has potential energy, and the potential energy is 100 joule. Are you following now? But the kinetic energy is 0. Now let's add. We say mechanical energy. We say mechanical energy is equal to potential energy plus kinetic energy. Potential energy here is 100. Kinetic energy here is 0. 100 plus 0 gives us 0. So at this point here, the mechanical energy is still 100. Now let's say this object falls to a point where to have the distance. Let's say to have the distance here. Okay, so half the distance means height will become 2.5 meters, right? Good. So our potential energy at that point will be what? So to be mass, the mass means then 2 times 10 times 2.5. 2 times 2.5, 5 times 10, 50. So potential energy at half the distance is 50 joule. Kinetic energy at half the distance will also be 50 joule. Now, if you ask me how is that, the reason is this is because if you find the velocity with which it falls, that's what we want to use to answer this question. I don't want to jump into conclusion here. So if you find the velocity, and from the velocity you find the kinetic energy, you find that K is 50 joule. Yes, it will be 50 joule. Now, I want you to add the mechanical energy and the potential energy together. Potential energy and kinetic energy will give you what? 50 plus will give you 100. You see that mechanical energy still remains 100. When the object gets to the ground, potential energy becomes 0. How? Because the height is 0 now. So if you put h equals 0 here, anything times 0 will give us 0. So height is, the potential energy becomes 0, the kinetic energy becomes 100. If you add 100 plus 0, it will give you 100. So from what we have seen, you will notice that, what do you notice? You will notice that mechanical energy remains the same all through the motion. Potential energy reduces as it goes down. Why does it reduce? Because the height is reducing. Please take note that potential energy is a function of height. As height increases, potential energy increases. These are potential post-UTME and JAMB questions you can see. As height reduces, potential energy reduces. Similar thing with kinetic energy. If I throw a stone up, you will notice that as the stone goes up, its speed will be reducing, its velocity will be reducing as it goes up. As the velocity is reducing, kinetic energy is also reducing. This is why the higher you go, kinetic energy reduces, potential energy increases. As the stone begins to fall down, the speed increases, right? Speed will be increasing as it's falling down. So as the stone is falling down, because speed is increasing, kinetic energy will increase. And as it's falling down, what happens to the height? The height reduces, potential energy too will reduce. It's a simple, see, physics is reality. Carry physics to be realistic with physics, you will not feel it. You will not feel the question. But this is not where I'm going. So what do we observe? We observe that potential energy changes, kinetic energy changes, but mechanical energy remains the same. So if they ask you which of the following is constant in motion, A, kinetic energy, B, potential energy, C, mechanical energy, D, one other option. So mechanical energy is the correct answer because it is constant. It does not change, because at every point in time, when you add kinetic energy, potential energy, it will give you mechanical energy. The reason for this is because of energy conversion. That law, in a closed state, energy is not created, energy is not lost, but energy can be converted from one form to another. So the whole thing that plays here is that as the object falls down to the ground, the potential energy is not lost. No, what happened to the potential energy? It was converted to the kinetic energy. Potential energy was converted to kinetic energy. So as the object falls, so here we have initial kinetic energy, here we have final kinetic energy, here we have initial potential energy, here we have final potential energy. So by virtue of this law, we know that the mechanical energy is equal to potential energy plus the kinetic energy. As easy as that. So what is the potential, the difference? Because the total potential energy is the difference. Final potential energy Pf minus initial potential energy Pi plus final kinetic energy Kf minus initial Ki. This is what we get. This is what our mechanical energy actually is. So the actual way of actually solving physics question anytime that deals with energy is because you have to include your final potential energy, initial potential energy. You have to include your final kinetic, because the reason many of us used to remove initial most time or remove final most time is because the object started from rest. So if the object started from rest, my initial kinetic energy is 0. So this one, there is no need for me to put it since it's 0. That's why many times we always remove it. But imagine a question tells you that an object falls with a velocity, initial velocity of 3 meters per second. Find the final kinetic energy. You cannot remove it. You cannot just use Kf. You have to include the Ki because it actually has a velocity, so it's not 0. Are you getting the concept? So physics is actually not difficult. So now let's move to this question and see what we have here. Now we are using the process of energy conversion. So energy conversion, that potential energy will be converted to kinetic energy. Is that not it? Kinetic energy. So when we say energy conversion means that my potential energy, if the object is falling, will be converted to what? My kinetic energy. Potential energy is converted to kinetic energy. It does not mean equal, actually. It just means that it is converted to this. So my final potential energy minus initial potential energy is equal to final kinetic energy minus initial kinetic. This is just in literal terms, does not mean this and this are equal. Okay, does not mean it is. The only point where this and this are equal is when it's at the middle of the journey. Yeah, that's the only point. But the whole thing here is, the whole thing I'm trying to explain here is that, my potential energy is being converted to my kinetic energy. It is not lost. That's how I'm equating it. So let's look at this question now. A 5 kilogram mass is dropped from a height of 30 meters above the ground. So let's say I want to draw the diagram. This is my ground. This is my ground level. This is my ground level, okay? This is where the object is. The distance of the object from the ground is 30 meters. So the object is 30 meters from the ground. Are you following me? Determine the velocity of the mass when it is 80 meters above the ground. not on the ground, 18 meters above the ground. So let's say this is a distance of 18 meters above the ground. This is where 18 meters is. So what the question is asking us is that the object fell from this point 30 meters to this point 18 meters. What is the velocity of the object when it reaches here? So the object was falling here, it got here, it got here, it got here, it got here, and eventually it reaches this point 18 meters. The question is now asked, at this point 18 meters, what is its velocity? It's very, very simple. We are going to be using the principle of energy conversion. So let's go first. Before the object started falling, at this point here, its kinetic energy, its initial kinetic energy was 0, right? Before it started, because it has no velocity initially. Before I started falling, imagine me holding the object like this. As it started falling, no. So before I started falling, its initial velocity is 0. Because initial velocity is 0, kinetic energy initial is 0. So the initial kinetic energy, let me call this Ki, is 0. Are you following me now? Now let's move to Kf, Pi. Because what we have here, we have both kinetic energy initial and potential energy. My initial potential energy, Pi, is caused by what? Mgh. Hope you know it's not 0. Why? Because it has a height. So using the formula they gave us from the question, mg, the mass is 5 times gravity is 10, h is what? Height is 30. At this height here, so 30 3 times 5 15, that's 1500 meter. Joule energy, unit of energy is joule, not meter. So at this height 30 meter, my initial potential energy is 1500 joule. My initial kinetic energy is what? 0 joule. Now the object fell to this point here. So at this point here, what is my final kinetic energy? Kf. Hope you know it's not 0, because now the reason it will not be 0, because at this point here, the object actually has a velocity. It was not like at this initial case where it does not have a velocity. At this point here, it does has a velocity. So the velocity at this point is the velocity at this point, we don't know it. That's what the question is asking us to find. So we don't know it. So if it has a velocity at this point, it means it will have kinetic energy at this point. And since this is the final point according to the question, that's what this way we are taking as our final point according to the question. The question did not go beyond 18 meters. So this will be our final point. So final kinetic energy here, we don't know it here. For we to get the velocity at this point, we have to get our final kinetic energy. So we don't know it. Let's just write it down. But our final potential energy, Pf. Final potential energy here, we still use the formula mgh. What is our mass? 5 kilogram. G is 10. The height, are we going to use 30? No, we are going to use 18 meters, because that's the point we are now, times 18. So using our 5 times 10 times 18, 900. So the answer, the potential energy here is what? 900 joule. Now that we have gotten all of this, now let's use our principle of energy conversion or energy conservation to solve this question. So from what we understood already, we say mechanical energy is constant, right? Mechanical energy is equal to potential energy plus kinetic energy. Are you with me? Mechanical energy is equal to potential energy plus kinetic energy. So if I take my mechanical, since it's a constant, if I take it to be 0, so we have potential energy plus kinetic energy is equal to 0. So if I bring this on to the other side, I'll have potential energy is equal to minus kinetic energy. How? Because from here, P is equal to 0 minus K. 0 minus K will give me minus K, right? If you take away 0 from anything, you'll still get that same thing. So P equals minus K. Don't be confused about the minus. The minus is only trying to show us direction. The opposite is conversion, okay? So let's go. What is potential energy now? We have potential energy Pf minus Pi is equal to minus into bracket Kf minus Ki. Don't be confused. My Pf minus Pi is actually, Pf means final potential energy minus initial potential. Because potential energy, like I explained earlier on, is that most times the reason why we remove the Pi and Ki is because it is 0. But there are some cases where they are not 0, just like in this case now. My initial potential energy is 1500. My final potential is 900. So it's not 0 in this case. So we have to include it. Because this is the proper way of doing it actually. The other one we'll just do, just because we'll just assume it to be 0 and just no. But this is the proper way of doing it actually. So final potential energy minus initial. What this means that I am the potential energy of that body, because the body moved from point A to point B. Definitely it has initial potential energy and final potential. So I can't just write potential energy. If I just write potential energy and I solve it and got the answer, it means that I subtracted my potential energy without putting it in writing. Because what most people will do, they'll just say 1,500 minus 900 without putting it. But this, for those of you writing WAEC, although all these things have to be there because they carry mark. So let's move on. What is my final potential energy? 900 minus, what is my initial potential energy? 1,500 minus, if I open this bracket, I have minus Kf plus Ki, because using mathematics, using this to multiply the bracket, minus times Kf will give minus Kf, minus and minus will give plus in mathematics now. So let's now impute the value for this. 900 minus 1,500, we have minus 600 minus Kf plus, what is our Ki? Our initial kinetic energy is 0, we already know it. So our answer was to give us minus Kf. You can see that this minus will cancel this minus. We have Kf equals 600 joule. As easy as that. So these are the minus cancel out, because if you do it the proper way, you will not be getting minus in between. So potential energy plus kinetic energy is equal to 0, a constant 0. So just our mechanical energy is constant. So if we just take kinetic energy to the other side or take potential energy to the other, it will carry minus. Just solve it and break it down. The reason this is taking much time is because I'm trying to explain it. If you see it, just use this diagram. You are done. Okay, are you following me now? So let's go. Now remember, the question did not ask us. Question did not ask us to find kinetic energy. What is it asking us to find? It asks us to find the velocity. So this is the kinetic energy at the point 18 meter, but we need the velocity. So using the formula for kinetic energy, we have kinetic energy is equal to half mv squared, right? Half mv squared. So just make v squared subject to the formula. This will give you v squared is equal to 2 times kinetic energy over mass, right? So v squared is equal to 2 times 600 over 5. When you press your calculator, you have 2 times 600 divided by 5. That's 240. Now v will be equal to square root of 240. The square root of 240 is what? Press calculator. That's 15.49. Approximately 15.5. So that's the answer, option B. So you can see that it's very, very easy. It's not even difficult. Instead of you to go and be making mistakes, just alight this thing like this and just solve it, and you are good to go. There's no much problem there. So this is how you solve and get your answer very quickly. And sometimes when I see questions like that, I don't even need to solve. I just imagine it in my head. I'm like, okay, up, down. So if this body begins to fall, the velocity reduces, and all the rest. I hope you learned something. To follow us to get more videos like this.